Last session, we are done with something called as upcasting and downcasting. Correct. So we have seen a beautiful topic that is nothing but upcasting and downcasting for everyone. You should be aware of this particular topic here. So in today's session here, it's the continuation of it. Okay. So we are supposed to talk about something called as class cast exception. We generally come across something called as class cast exception here. So what is class cast exception? Everything we will try to discuss in today's session over here. Okay. Now imagine guys, let me have this particular hierarchy here. Okay. I will have a beautiful classes, a couple of classes here so that you can all understand it in a beautiful manner. Okay. See guys, I will have a class called as father here. Okay, and I will have another class called as son and another class called as daughter over here. Okay, so what did you understand over here? As of now, there are three classes: father, son, daughter, and there is a relationship between them here. Is a relationship is nothing but inheritance. Okay, so daughter and son are the subclasses of father class here. Okay, so what is upcasting? What is upcasting? See here, upcasting is nothing but creating an object of subclass. Okay, we are creating an object of subclass and storing its address into a reference which is of type superclass here. So what did you understand over here, sir? We are creating an object of subclass and storing its address into a reference which is of type superclass. So that is called as upcasting. So upcasting means superclass reference subclass object here. And upcasting will always happen implicitly. And what is the prerequisite for it? Inheritance is the prerequisite. Got the clarity here? Okay. And this F is of type father. So with the superclass reference or with the upcasted reference, I can access only the superclass properties, not the subclass properties. Okay. Since F is of type father, I can access only father class properties, not the subclass properties here. Then what is downcasting? Sir, the upcasted reference F, I am trying to convert back to subclass type reference here. F is of type father. I am trying to convert it to son of type S here. So the upcasted reference, I am converting back to subclass type reference here. And we have to do it explicitly, and upcasting is the prerequisite. So how will I do it explicitly? To which type am I trying to convert? Son. So I have to write son over here. But if I write it as son, that becomes like declaration. We need to cast it. How? Within parentheses, I need to do it. So upcasting implicitly, downcasting explicitly. For upcasting, inheritance is mandatory. For downcasting, upcasting is mandatory. With the superclass reference, only superclass properties. With the subclass reference, both superclass and subclass properties can be accessed. And I have told you the definition as well. Okay, this is all about upcasting and downcasting, and this is what I have written it down over here. Non-primitive casting meanings class type casting. So there are two types, upcasting and downcasting. That's it. Okay, so we're done with this entire process. So in today's session here, we are going to talk about something called as class cast exception here. Sir, what is class cast exception, sir? I will tell you here. Okay, see here. If son if sun has upcasted, okay, we have to downcast it to sun only. If daughter has upcasted, we have to downcast it to daughter only. Meaning, see here, if who is upcasted over here? Who is upcasted? Sun has upcasted. We need to downcast it to sun only. If not, we will get class cast exception. For example, see here, upcasting, see, creating an object of subclass, okay, and storing its address into a reference which is of type superclass. creating an object of subclass and storing its address into a reference which is of type superclass. This is upcasting. Who has upcasted? Sir, Sun has upcasted. Who is upcasting? Sun has upcasted to father type reference here. Now I have to downcast it to father, son only. I cannot downcast it to daughter. But the upcasted reference, I am trying to downcast it to daughter type reference here. I'm trying to convert it to daughter type reference. So what has happened here? Son has upcasted to father, but we are downcasting it to daughter. So we have to do it explicitly. We have to do it explicitly. But now we will get an exception. What is it? Class cast exception. What do we call it as? Class cast exception. Why? Because here there is father. Okay. And there is son and daughter here. Son and daughter. And there is a relationship between them. What is there? Is a relationship between them. So if son has upcasted, we have to downcast it to son only. If I do not downcast the son and downcast it to daughter, we will get class cast exception here. Got it? So this is what I have done. See here, if a object has been upcasted, we have to downcast to the same type. Okay, if son has upcasted, downcast to son only. If daughter has upcasted, downcast to daughter only. So if one object has been upcasted, we have to downcast to the same type only. If not, we will get class cast exception. In other words, if one type of reference is upcasted and downcasted to some other type of reference, we get class cast exception. Both means the same. Okay, if son has upcasted, we have to downcast to son only. If I downcast to daughter, we will get class cast exception. Got the clarity here? For example, see, I'll tell you one more story here. Son wants to go for a trip, okay, with his friends. Son wants to go for a trip with his friends. The son will request money from his father. Father, me and my friends are trying to go for a trip here. I want 10,000 rupees. Okay. The son is requesting for some money from his father. So now the father has to give the money. To whom will he give here? To son or daughter? So son has requested the money, but father is giving the money to the daughter. Don't you think so? There is some problem here. Son requested, you have to address the son here, not the daughter. So it's a problem. We will get class cast exception. Got it? Again, one more fine day. Daughter will like, dad, father, I want to go to shopping with my friends here. Okay, you please give me 10,000 rupees here. So the daughter is requesting her father that father, I want to go for shopping. Please give me 10,000 rupees. Now father will give the money to son here. So don't you think so it's a problem? Daughter requested the money to father. Father has to give the money to daughter, but he's giving the money to the son here. Therefore, if one object is upcasted, we have to downcast to the same object type. If not, we will get class cast exception. And also, even if we downcast without upcasting, okay, we have not upcasted at all. Directly we're downcasting. Again, we will get class cast exception. Got it? So these are the scenarios we come across with the help of class cast exception. Okay, now see, if one type of reference is upcasted, we need to downcast to same type. Okay, if we don't downcast to same type, and if we downcast to some other type, class cast exception will appear here. Got it? So now here, if again, if we upcast, I mean, if we are trying to downcast without upcasting, we will again get class cast exception. So how do we avoid it? We avoid it with the help of an operator called as instance of. Okay, we are trying to avoid this class cast exception with an operator called as instance of. How? I will prove it to you practically. Okay, so I want everyone to concentrate over here. Trust me, by the end of the session here, you'll be strong at this particular topic. Okay, so have patience for it. Okay, so we already have created a project called as typecasting. Now under SRC, okay, let me create a package, and the package name is, you can give any package name, and the package name is com. Project got created, package got created. What is the next part here? I have to create a class here. Control N, I will create a class and the class name is father. Okay, what is the class name? The class name is father here. Got it. So this is what we are supposed to understand, right? Perfect. So now what did you understand over here? What did you understand over here, sir? There is a father class. Okay. So there is a package called as com, meaning there is a folder called as com, and father.java file is present in com folder. Class is a blueprint of an object. Okay, it's a platform to store the states and behaviors of an object. And public is the access specified, meaning if a class is public, everyone can access this class. Okay, and the father is having a variable called as x, which is initialized to 30. Okay, and I'll have one more class called as son. Okay, again control n, and I'll have one more class called as daughter, and I'll have one more class called as control n, create a class, and the class name is test here. Okay, so I'm trying to align the code and explain it in a beautiful format here. Okay, so try to understand over here in a beautiful manner over here. Okay, so yeah, perfect. So we have got the expected content over here. So actually speaking, we have how many classes over here? We have a couple of classes over here. Okay, see guys, first everyone understood, I believe. We have a father class which is having a variable x initialized to 30. And now I need to achieve easy relationship. Okay, I will tell extends. Okay, extends is used to achieve inheritance. Extends father here. Okay, so when I tell extends father, it means son is acquiring the properties of father, and son is having a variable called as y initialized to 20. Okay, and daughter is also achieving easy relationship with his father. Extends father, and again int z equals to 10 over here. This is all about the actual content here. So I hope everyone are aware of what is happening in this respective class here. Got it? Perfect, no? So now I will have my main method wherein the execution will always begin from. Okay, and what type of relationship is this? Father, son, and daughter. Okay, what type of relationship is this, guys? Think and tell me. Okay, I want answers from everyone here. Father is the superclass, son and daughter are the subclasses inheriting the same class. Hey, I know it is easy relationship, but what type of easy relationship? This is inheritance, easy relationship, perfect. But we have different types under it now. Okay, single level, multi-level, hierarchical, multiple, hybrid, right? So what type of relationship is this? Is it multiple or multi-level? Is it multiple or multi-level, guys? Multiple or multi-level? You're getting confused, okay? Tell me one thing, multiple or multi-level? Okay, great, great. Oh, very good, guys. Very good, guys. Okay, for everyone who told multi-level, no, slap yourself once. Okay, tight slap. Okay, give yourself once. Okay, so the reason is I'll tell you here. Okay, multiple is different from hierarchical. Okay, na. For everyone who told wrong answers, no, slap yourself once. Okay, see here. A, there is class A and class B. Okay, so here B is the subclass, A is the superclass. This is single level inheritance. Why? Sir, a combination of one superclass and one subclass is called as single level inheritance. Clear? Name itself tells multi-level. Class A, class B, class C, class D. D inherits from C inherits from A inherits from, D inherits from C inherits from B inherits from A. This is called as multi-level, meaning multiple superclasses and subclasses in a sequential manner here. Got it? So never ever go with what I tell. Okay, I might try to manipulate you. Okay, you have to be confident in your own answers. Okay, so this is what I was just trying to check. If you're going with my flow, are you confident with your own answers here? So never ever go with, oh, I as soon as I try to manipulate, Don't change your answers. Stick to one answer. Even if you're wrong, stick to one answer. Okay. So as and when I start manipulating you, oh, are you sure this? Don't go. Okay. You have to stay confident. Okay. This is single level and this is multi-level. Now, I told you father, right? Son and daughter. This is one thing. And this is A. Okay. Father, mother, and this is son. Imagine. Okay, so now get the difference here. One superclass and multiple subclass is called as hierarchical inheritance. What do we call it as? Hierarchical inheritance. But one subclass having multiple superclasses is called as multiple. Don't go wrong. This I have done it in inheritance. Okay. One subclass having multiple superclasses is called as multiple inheritance, which is not possible in Java. I have not told why is it not possible, but I'll tell you. Don't worry. Okay. And one superclass having multiple subclasses is called as hierarchical. So in my current program, sir, son is also inheriting father and daughter is also inheriting father. So one superclass but multiple subclasses. So what type of relationship it is? It is hierarchical inheritance. Got it? I hope you all got the clarity about this entire process here. Right? Perfect. Very good, guys. Okay, I hope now you'll not go wrong anytime. Okay, in the near future, you will never go wrong with inheritance, especially easy, hierarchical and multiple. Never go wrong. Okay, perfect. So now here, what is upcasting? Sir, it's simple, sir. Upcasting, creating an object of subclass, okay, and storing its address into a reference, which is of type superclass here, which is of type superclass. So what is happening here? Sun has been upcasted now. Okay, who is upcasting? Sun object is being upcasted. So I have to downcast it to sun only. But if I downcast it to daughter, okay, if I downcast it to daughter here, see what happens? See, sun as upcasted and this F, which is of type father, is storing sun object. Okay, is storing sun object. But if I try to downcast it to daughter here, okay, explicitly I'm casting. And now when I execute it, look at the huge exception what I get here. Okay, just look at the huge exception what I get here. See, exception in thread main. Okay, it's giving a huge part. See, exception in thread main meaning exception has occurred in the main method. And what is the exception? Class cast exception. And why is it occurring? Son cannot be cast to daughter. It's telling, hey, dabba fellow, you are upcasting son object, but you are downcasting it to daughter object. How is it possible here? It's not possible. He's slapping nicely, scolding me. Okay. So, and he's also telling, hey, line number 8 is the problem. Okay. Okay. As a programmer, I got to know, oh, line number 8 only there is a problem in line number 8. Oh, I'll check. Oh, what is the problem? Okay, okay. Son object has been upcasted to father type. So this has to be downcasted to son type only. If I downcast to daughter type, I will get an error. Got it? Imagine if it is daughter object. If it is daughter object, okay, will it be a problem here? See, if I execute it here, I'll get no output here. Why? Because there's no print statements at all. See, there's no output. If I open the console, there's no output. Why? There is nowhere print statement used. So what will it print here? Nothing it will be printed. Got it. So when do we get class cast exception? If one type of object is upcasted and we downcast to some other type, we get class cast exception. Got it over here? Understood. So now, okay, so how do we avoid it? We avoid it with the help of instance of. Okay, what is instance of? I will tell you the data here. What is the job of instance of here? I will tell you here. See, what is instance of? It's an operator. What is that operator doing? It is used to check if an object is an instance of a specific class or not. If an object is having the properties of a specific class or not. Okay, so it will return a Boolean value. So the syntax is object instance of that respective class name. In order to avoid class cast exception, we have to come across the data here. This is the reason I'm getting the class cast exception here. Okay, I hope you all got the clarity. So now when I execute it over here, see the huge class cast exception I'll get. Okay, I got the class cast exception. So how do we avoid it over here? We avoid it with the help of instance of. What is this instance of? I will tell you here. Before that, we will try to understand, okay, the meaning of instance of. See, this is a normal sum object. This is a normal daughter object, and this is a normal father object here. Okay, no upcasting, no downcasting, just a normal class. So now look very carefully here. Okay, closely observe. S is storing the sun object. Do you all agree? S is storing the sun object. Okay, so S is the object of sun. S is the object of sun, instance of sun here. So it means S is the object of sun. So is the object of sun having the properties of sun class. Is it true or false here? So the output will obviously be true here. Why? Why is it true here? Guys, common sense. When I create an object of sun over here, will it have the properties of sun? Obviously no. S is the object of sun. It is having the properties of sun here. So therefore the output is true here. Similarly, S is the object of sun. Is it an instance of? Is it having the properties of father? Can you tell me? Will it be true or false here? Is the sun object having the properties of father? Common sense. Son is inheriting from father. So when I create an object of son, it will have the inherited properties of father as well as the explicit properties of son. So when I create an object of son, he will have the properties of son also, father also. So it should also be true. Correct. So once I execute it, I get the output as true here. Yes, I got the output as true here. Similarly, D instance of, okay, D instance of daughter. What did you understand? Sir, what is D, sir? D is the object of daughter. Okay, D is the object of daughter. Is the object of daughter having the properties of daughter class? Is the daughter object instance of daughter class? What should be the output? 101% the output should be true here. Why? Because the daughter object will have obviously the properties of daughter. Correct. Similarly, the instance of father. Now what will be what am I going to check? D is nothing but the daughter object. Is daughter object having the properties of father class? True. Why? When I create an object of daughter, it will have the properties of daughter and father. Why? Because father is being inherited. So the output again will be true. Correct. So let me cross check. Okay, let me cross check. Did I get the output here? Yes, I got the output as true here. Okay. Now similarly over here, apply common sense here. Instance of father here. What should be the output here? F is nothing but the father object. F is nothing but the father object. Is the father object instance of father class? Is it having the properties of father class? Obviously no, it should be true here. Father object will have the properties of father here. The output will be true again. But now when I tell F instance of son here, what will be the output, guys? Think and tell me here what will be the output here. F is nothing but the object of father. Is the object of father instance of son class? Meaning, is the object of father having the properties of son class? Will it be true or false here? It should be false. Very good. So now when I execute it, did I get the expected output as false here? Absolutely. Why? Because son will have the properties of father. Father will not have the properties of son. Correct. Similarly, I will tell F instance of daughter. Now what should be the output? F is nothing but the father object. Is the father object having the properties of daughter? Common sense. Very good. You all got the clarity of it now. So now when I execute it, obviously it will give me false here. So it should give me false. Very good. So you all understood what is instance of. Perfect. Got it right. So everyone understood what is instance of. We could do it either directly also. How can we do it directly, sir? See, simple. I will directly create an object of sun. See, new sun of. This is an object of sun. The object of sun, instance of father. Okay, we can do it directly also. So I have created an object. See, sun object. I have created an object of sun. No, is sun object instance of father. Is it having the properties of father? Obviously, the output should be true over here. Okay. Similarly, new father object instance of daughter. I'm just doing it randomly. Now what will be the output? New father meaning is the father object instance of daughter here? No, father object is not an instance of daughter. So here it should be false here. Okay. So now I'll tell new daughter instance of daughter itself. So what should be the output now? Is the daughter object instance of daughter? Yes, it is true here. So the output should be true, false, true. Correct? So last part. Did I get the output? True, false, true? Yes. So this is what we are supposed to understand with respect to instance of. I hope you all got the clarity about what the hell is this instance of, right? So instance of is used to check if one object is an instance of, or is it having the properties of a specific class or not. Okay, see, son, father, these are all the classes. Whatever is in the RHS, these are the classes. S, these are all the objects. Son object, daughter object, father object. You can also write directly also. New son meaning it's an object of son. Correct. It's an instance of father. True. Is the father object instance of daughter? No. Is the daughter object instance of daughter only? True. So that way we are supposed to understand the entire program here. I hope you all got the clarity about what is class cast exception and what is instance of. So we learned both the topics separately. We understood class cast exception separately, instance of separately. Now we are supposed to combine it now. Okay. How, sir? I will tell you. Okay. Don't, okay, get diverted over here. Okay. Try to concentrate. Try to concentrate. I'll have a class called as solution. Same class. I will have my main method. Okay. So now I will tell sys out start. Okay. At the beginning. Okay, and end at the last for my understanding. Okay, you don't like it, don't write. Very simple. Okay, just for my understanding. Now guys, what is upcasting? Creating an object of subclass and storing its address into a reference which is of type superclass. This is simple upcasting over here, right? Now here I will downcast it to daughter. Okay, so if I try to do it daughter, explicitly I need to do it because downcasting will happen explicitly. What will be the output? What will be the output, guys? Only start and end? Or what should be the output? Just tell me, what should be the output of this program? Okay. Okay. Majority of you have given me, different types of answers. Okay. Okay, guys, observe carefully. Sir, execution always starts from main method. Start will definitely get printed. Now, creating an object of subclass and storing its address into reference of type superclass, meaning upcasting. Son object has been upcasted. Here it is daughter object. So son is being upcasted. So we need to downcast it to son only. If I'm downcasting it to daughter, we will get class cast exception. So when I execute it, okay, start will get executed and exception will occur and your program will get terminated. See, start exception in the main method. It's class cast exception. Why? Son cannot be downcasted to daughter. And line number 10 is giving the exception. So your program got terminated. Abrupt termination. Start got executed. As soon as you're trying to downcast it to daughter, class cast exception got occurred and your program got terminated. Okay now. But how do we avoid it? How do we avoid it? We avoid it with the help of instance of. Okay, we avoided, try to avoid it with the help of instance of. How? Okay, I will tell you here. Okay, now closely I'll tell you. Okay, how do we work around with instance of? Very good, very good. Okay, so here what I'll do, if else condition, I'll make use of one if else condition over here. Okay, this is how the basic syntax of if else looks like. Correct? No, if open parenthesis close and then else here. So now I will tell if instance of sun. If it's the object of sun, instance of sun here, okay, then we have to downcast it to sun here. So we have to downcast it to sun here. So here, okay, I'll just write it as sys out downcasting to sun. I'll just write it as downcasting to sun. Okay. Else if f is an instance of something else. Okay. For example, daughter. I will just write it as sits out downcasting to daughter. Downcasting it to daughter. Now closely observe. Okay, we're done with the program actually speaking. Okay, see, start and end, I'm just going to remove it off. I don't want to complexity, reduction. See, this is upcasting. You should all agree with this, correct? Which object is stored into F here? F is storing the object of sun here. Okay, F is nothing but the object of sun. So, object of sun, is it having the properties of sun class? Is it true or false? True. So, if true, if block will get executed and the else if block will never get compared at all. So, the output will be downcasting to sun. Correct? Did I get the output as downcasting to sun here? Absolutely, I will get the output as downcasting to sun only. Okay? Similarly, if I am storing an object of daughter, so daughter object is stored into F here. F is nothing but daughter object. Is daughter object having the properties of sun? Is the daughter object instance of sun? No, else if. F is daughter object. Is daughter object having the properties of daughter? True. Downcasting to daughter. So we make use of instance of in order to check if an object is an instance of, is it having the properties of a specific class or not? Okay. So now I will downcast. How will I downcast it? F is of type father. I need to convert it to son and store it into reference S here. So after downcasting, I can access the superclass properties of X also, plus I can access the subclass property Y also. F is of type father, only superclass properties I can access. Now I can downcast it to son. I checked, oh, is the daughter, so son object having an instance of son? Yes. I need to downcast to son. I will downcast it and I can access both the properties. Similarly, if it is daughter part, okay, if it is daughter object, I have to, daughter D. So I have to downcast it to daughter. So now over here, I will write it as explicitly. So with the reference of D, I can access the superclass property and I can also access the subclass property. This is all about the entire program here. See here, downcasting to daughter, and I'm accessing the father property 30 and the daughter property 10 here. Sir, what happened, sir? I will tell you, see, new daughter. Daughter object is stored into F. What is F now? Daughter object. Is daughter object having the properties of son? No. Else if. Is daughter object having the properties of daughter? Yes. We are downcasting it to daughter. The instruction how to downcast it to daughter, and with the after downcasting, I'm accessing both superclass and daughter class property. Got it? But now, when I have son object, what am I trying to do here? New son. Son object is stored into F. Is son object instance of son class? True. We are supposed to downcast to son and we are explicitly downcasting it to son and accessing the father and son class property. So now when I execute it, did I get the expected output here? Yes. So this is how we are supposed to understand downcasting and upcasting and instance of. Why do we make use of instance of? There is a possibility of class cast exception, mismatch. Okay. Therefore, we avoided with the help of instance of operator here. Okay. I hope you all got the accessibility of this entire program here, right? Similarly, shall we do similar kind of program here? Okay, shall we do one more similar kind of program here? Absolutely. But this can also be done in two ways. How? Sir, I will declare it separately, sir, and I will initialize it separately, sir. Possible, no? See, declaration and creation. Hey, it's very simple, guys. See, int a equals to 10. What does it mean? Sir, declaration and initialization. Can we do it in two lines? Int a is declaration, a equals to 10 is initialization. The reason it's giving an error is because we have already declared it. See, this is declaration and initialization, and here we are trying to do it in a single line here. Got it? So this is declaration and initialization separately. Here we're doing it together. Oh, similarly over here, this is declaration separately and creation of an object separately. We can do that as well. F is of type father, so it can store the son object also, daughter object also. Generalization, which I told in the previous session, correct? Or else you don't like it, directly write father F equals to new son of. That way also you can do it over here. Okay, so that way also you can do it over here. Okay, got it. This is all about it, guys. Okay, so you can use whichever way you want it. Okay, I'm just giving you the clarity about both the things here. Okay, so we just understood one example over here, but I'll do several examples. That is when you'll have the complete clarity of it. Okay, one, two programs, you'll not have fun. I'll do so many programs for you all so that you should be able to understand over here in a beautiful manner. Okay, great. Okay. Okay, so there's one question. Since I have easy relationship without downcasting, can I access both properties here? Your answer is no. Okay, you might have stored the son class object in father reference, but f is of type father. So now when I tell sys out f dot, I can only access the properties of father. But if I want to access the properties of son, no, it will give an error. See, it's giving an error. So y cannot be resolved or a field. So f is of type father and I can access only father class properties. You might tell, sir, I have created easy relationship and I have created an object of subclass only. But since it is upcasted, with the upcasted reference, only superclass properties are visible to me. So therefore, I can access only father class properties. But I need to access son class properties as well. No, that's the reason I am trying to downcast it over here. Got it? I hope you got the basic idea of it now. Okay, perfect. Good question. Good question. Okay, right. So now let's go with one more example here. Okay, simple example here. I will have a class called as vehicle. Okay, here I will have one data called as brand initialized to Audi. Okay, so I have one program here, guys. I have a class called as vehicle, wherein it has a variable called as brand, which is initialized to Audi here. And control N, I will have a class called as car, and I'll have one more class called as bike here. So now I want to achieve easy relationship here. How do I achieve easy relationship over here? It's very simple over here. Sir, I have to tell extends vehicle. Okay, after vehicle, bike is having a property called as cost to 5,000 here. The cost of the bike is, imagine it is $5,000. And car extends vehicle. Okay, and this is having a property called as fuel initialized to petrol here. Okay, right. So what kind of relationship is this? Now if you give me wrong answers, no, okay, I'll only come and slap. Okay, it's not that you will slap, yeah, I'll only come and slap. It's simple. Okay, very simple, guys. Sir, one super class called as vehicle, sir. Bike also is inheriting vehicle. Car is also inheriting vehicle. Sir, one superclass and multiple subclasses is an example for hierarchical inheritance. Very good. Okay, I hope everyone got it. Okay, na? Perfect. Okay. So now here, okay, great. So now here, I want one more class. Class, test class. Okay, test. With test, we already have it. So we'll write it as a demo class. Okay. Now we'll try to, understand this program in a beautiful manner. Right. Beautifully, we will try to understand this program. Right. Guys, see here, I'll have my main method wherein the execution will begin from. So now, so if I write car C equals to new car of, okay, into a single reference C, I can store only car object. Why? C is of type car. I can store only car object. This is specialization. Okay. And here for bike, bike B equals to new bike here. These two are an example for specialization. Why? C is of type car, I can store only car object. B is of type bike, I can store only bike object. But into a single reference, I should be able to store both the type of objects. Then I'll make use of upcasting. See, vehicle obj equals to new car of, that is upcasting. Why? Creating an object of subclass, storing the address into reference of type superclass. Obj is of type vehicle. I can store car object also, and I can store bike object also. Both will work. Okay, that is generalization. Got it? So done. So now here, when I downcast it, there is a possibility that I might downcast it to car also, I might downcast it to bike also. But at times we might come across, okay, at time we might come across some issues here. So therefore, we have to make use of instance of an if-else condition. So if obj is an instance of bike, what does it mean here? What does it mean? So we have to access the properties of bike here. We can directly write else also, doesn't matter. See here, new bike. Bike object is stored into obj. So obj is storing bike object. Is bike object instance of bike class? Is the bike object having the properties of bike class? True. So we have to downcast this obj to bike type reference here. Okay, but we have to do it explicitly. Downcasting will always happen explicitly over here. Okay, and I will access both superclass property, that is the brand, and the subclass property, that is the cost here. So B is of type bike. I can access both vehicle and bike properties. But OBJ is of type vehicle, only vehicle class properties I can access. Okay. Else, I can directly write because there are only two classes involved. I'll directly cast it to, again you can write else if also. Else if obj instance of car, what will I do? I have to downcast it to car type here. Okay, I have to downcast it to which type? Car type over here. Car C here. Downcasting will always happen explicitly. So here we have to do it explicit cast over here. That is of type car here. Okay, that way we have to do it here. So once I'm done downcasting, I can access the superclass property also, and I can also access the subclass property also. This is all about if and else condition. See now, which object I have stored? See, this is declaration, and here I can initialize it later. In a creation. See, obj is of type vehicle. So I can store the bike object also, car object also. Generalization. So as of now, obj is storing the bike object. Okay, bike object. Is the bike object instance of bike class? Yes, true. You will downcast it to bike and you will access the properties of bike and vehicle. So when I execute it, did I get the expected output here? Yes, see, Audi 5000. Okay, I got the accessibility. Similarly, if I'm creating an object of car here, see, car object is stored into obj. I check. Okay, is the object of car instance of bike? No, car object will not have the properties of bike. Then, else if is obj instance of car? Is the car object having the properties of car? Yes. Downcast it to car and access the vehicle and car properties. So when I execute it, I got the output here. Got it? So this is all about upcasting, downcasting, what is class cast exception, and how do we avoid it with the help of instance of an if else condition. This is all about the entire process. Clear? Done? Perfect. Now tell me, do you see about a vehicle, car, bike, and so many things? But we will discuss even beautiful topics here. Okay. So what are those beautiful topics here? I will tell you here. Okay. What are those beautiful topics? I will tell you here. Okay. So now you have to apply a few common sense again, or a little bit of common sense. Okay. And tell me. So now guys, I will have a beautiful, okay, I will have a beautiful, what shall we take? M1 method. Okay, I will have a method called as M1. Okay, open curly braces, close. And now I am not returning any value. What will be the return type of the method here? What will be the return type of the method here? Think and tell me, what will be the return type of the method? Sir, you are not returning anything. So therefore, the return type has to be void here. Right? Very good. The return type has to be void. Now, similarly, as soon as I write it as return, okay, and I will tell it as 10. Sir, you are returning 10. So you cannot use it as void. When you use void, it's an indication that you are not returning anything. Since you're returning 10, based on the value you return, you have to decide your return type. It's supposed to be int. Very good. Now, I call the method. I call M1 method. So it goes here. Juk, 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 juk. The control goes to the M1 method. Return 10 meaning the control is again coming out. Juk, 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 juk. The control is coming back to M1 method with the value 10 here. So once a method is returning something, we need to store it. Okay, I will store it into a variable called as X. So what will be the data type of X here? It's simple, sir. The method is returning int value. That returned int value is only getting stored into X. So common here it has to be int only. Okay, I call the M1 method. Return 10 meaning 10 is returned. The 10 is getting stored into X and the data type over here is int here. Based on the value it is returning, I am deciding. Very good. Similarly, I have one more method, M2 method. Okay. So here I am not returning anything. The return type supposed to be void. But now I will tell return 5.5. Now what will be the return type? Sir, it's a decimal value, sir. Decimal value, just write the data return type as double. Okay, now simple. Now I will call the M2 method. Okay, I will call the M2 method. So now the control goes. The control goes to M2 method. Return 5.5 meaning the control is coming back to M2 method with the value 5.5. If a method is returning something, I have to store it here. I'll store it into a variable Z. Now, what will be the data type over here? Sir, the return type is double, sir. The data type should also be double here. Why? I call the M2 method return 5.5 meaning the value 5.5 is returned. That I will store it into a variable Z and that is of type double here. Got it? Very, very simple programs I've done. Sir, what big deal, sir? Why the hell did you do, sir? Wait. Okay. Now the main topic will start now. Okay. So what is that main topic, sir? I will tell you now. See, closely observe. Okay. Now, guys, everyone knows what is a class, don't we? Okay. Everyone knows what is a class here. Okay. So class, as I told you, it's an okay. As I told you here, class is a blueprint. Okay. Class is a blueprint of an object here, or it also act as a data type. So when I did the topic called as class, I always told you class is a blueprint as well as it acts as a data type, right? Okay. So now here, what am I trying to do over here is, okay, it's a blueprint, but still it can also act as a data type. Class can also act as a data type. Okay, don't worry about it. Okay. So now here, okay, we have two classes. Imagine the class name is class. I'll take the class name as imagine it is idli. Okay, what is the class name? The class name is idli here. Okay, breakfast time no. So I took it as idli class. You don't like idli, you write whatever you want. Okay, na? Simple. I'll have one more class. Okay, class dosa here. Okay, open curly braces, close curly braces. So I have two classes. class idli, class dosa. Okay. So now here you go to one hotel. Okay. Hotel, restaurant, wherever you want, you can go. Okay. So now you want to order food here. Okay. You'll have a method called as order method here. You'll have one method. What is that method name? Order food. Okay. Open parenthesis, close. And open curly braces, close here. Now here it will accept, this method will accept some choice. Okay. This method will accept some choice. Now I tell if choice is equal to 1. Okay, if the choice is equal to 1, what I will do, I will create an object of idli. Idli I equals to new idli of. Okay, and I will return that respective object here. I will tell return I. So what should be my return type over here? Sir, you are returning I. I is of type idli. The return type will be idli here, meaning a class is also acting as a data type, but that behaves as a non-primitive data type, which I will talk about it later. But as of now, a class is a blueprint. At the same time, it can act as a data type. Okay, so idli will be returned. Else if the choice is 2, if the choice is 2, it means, okay, I am creating an object of dosa. Dosa D equals to new dosa of. Okay, so here I have to return D. So what will be my return type? My return type can become dosa here. Got the clarity here? Perfect here. So what did you understand here? Sir, if the choice is 1, I will create an object of idli and I'll return the idli object. So the return type has to be idli. If the choice is 2, imagine the choice is 2. I will create an object of dosa and return the dosa object. So the return type has to be dosa. So there is a possibility that one method can have multiple return types. Okay, different types of return types. But it's not possible to write idli dosa, two return types. A method can have a single return type. Okay, but there is a possibility that the method is returning different types of data. So we cannot have multiple return types here. Therefore, what will I do, Okay, what is generalization here? What is generalization here? I will have, okay, a class called as food. Okay, I will have a class called as food here. Okay, and I will make the idli class inherit the food class. Okay, and dosa class inherit the food class. So dosa and idli are the subclasses of the class called as food here. So now tell me, if I have a single reference called as imagine, if it is food F, can I store the idli object also? Okay, can I store idli object here? Yes, sir. Can I store dosa object here? Yes, sir. I can store idli object also. I can store dosa object into the single reference type called as food here. So rather than using idli and dosa, multiple return types here, I can make use of a generic return type called as food here. Got it? So this will become like the upcasted reference. Okay. Now here, when I tell order and I pass it as 1. So control goes juk, 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 the control goes 1. Choice, is this 1? Is choice equal to 1? Yes, true. I will create an idli object and it is returning an idli object. It is returning an idli object. But now here, again, I will write it as food. I'll write it as some object, obj, and the return type is idli. Okay. Again, order, I will pass 2. So now I'll pass the choices 2 here. If the choice is equal to 2, those object will get created, return D. Those object is returned here. But now I cannot store it into idli, no? So the return type can either be idli or dosa here. So I cannot have two data types for a single reference variable. So therefore, the generic reference is food here. So it is returning idli object. Okay, see, if the method is returning an idli object, I can store it into food reference. If it is returning a dosa object, I can store it into food reference. This is all about the process. What is the advantage of generalization here? Got it? So now I will show it to you practically once here. Okay, I'll show it to you practically once here. Okay, so now I'll go back over here. Okay, I'll give you one such example over here. Okay, so now you will have a package, okay, package called as org, okay. Then under that, so now here I will have a class called as dosa here, okay, dosa class. I'm just doing in the high level view. If you want me to go in detail, I can go till the end here, okay. But I just initially I want you to understand the concept. Why the hell am I doing all of those? Okay, that's the reason here I took this particular example here, okay. So now here I will tell you one common fact here, okay. So observe carefully. For the people who still have confusions here, concentrate properly. So I have two classes here. What is it? Idli class, dosa class. Okay, dosa idli class. Then I have a class called as hotel. Okay, I have a class called as hotel here. So now here you want to, okay, order some food. So you'll have a method called as order food method. Okay. So now here, based on the choice, you are deciding the food you want to order. So in choice here, if the choice is, okay, if the choice is equal to 1, imagine, okay, I want to create an object of idli. I am trying to order idli here, okay, and I will tell return I, which is of an object of I. So what will be my return type? It should be idli. Okay, it should be idli. Why it should be idli here? It's simple, sir. If I pass the choice as 1, okay, is choice equal to 1? Yes. Idli object will get stored. Return I here. Okay, return I meaning idli object is written, therefore the return type is idli. Else if the choice is equal to 2, imagine it is dosa. Dosa D equals to new dosa of. And I have to tell return D. I have to tell return D. So when I tell return D, oh, there is a possibility that the method might return dosa object as well. Okay. Imagine I have one more class called as vada. Okay, whichever vada you want, whichever vada you like, you write it down. Okay, idli dosa vada. Okay, so we have three classes. Okay, so now over here, else I'll have an else block. If it's not 1, not 2, then obviously he will create a vada object and he'll give you vada here. Okay, so here return b. So what should be the return type? The return type should be vada here. So this is all about the program here. So you want the curly braces in the next line? Do it. No restrictions. Sir, I want in the same line? Do it. Sir, I want it in the different line? Do it. Okay, it's up to you. Okay, you have to decide everything. Okay, so there are a couple of classes here. That is idli class. Okay, so we have one more class called as dosa class, and we have one more class called as vada class. So now, if the choice is 1, I will create an object of idli and I'll return the idli object. So the return type can be idli. If the choice is 2, I will create dosa object and return dosa. And if the choice is 3, imagine. Is it 1? No. Is it 2? No. Else here, I will create an object of vada and I'll return vada object. So the return type is vada. So there are multiple return types here, but I cannot have multiple return types. I want a generic return type. Okay, generalized return type. So what will I do here? Sir, I will create one class called as food. Okay, I'll create a class called as food and I'll make sure that all the classes will inherit the food class here. Okay, so there is a class called as food over here. Okay, and I'll make sure all the classes will inherit. See, idli extends food. Okay, they have a generalized common class here. Just a moment, I'll just align the code here so that it becomes very easy for you all to understand. Okay, idli, dosa extends food. Okay, so again over here, okay, this is what is happening. Yeah, perfect. And here vada extends food here. So all the classes are having the super class called as food over here. Got it down? Okay, I hope you all got the specific idea about this specific content here. Okay, so no, I don't want to do it. Okay, so I hope it's aligned now. Okay, just a moment, guys. I'll align it because I want it to be visible for everyone. That's the reason I'm taking so much of pain and doing it. Okay, great. This is visible for everyone, I believe. Okay, great, guys. Yeah, perfect. Okay, idli, dosa. Yeah, perfect. Everyone can see it properly, I believe. Okay, so now here, since vada, dosa, and idli have a common superclass called as food, Rather than writing it as idli, dosa, vada, I'll just write it as food here. So I can have a generic return type. See, as soon as I write food, all the error gets vanished. Okay. So now you go to customer here. Okay, we'll have a class called as customer over here. Okay. So in customer class, what will you do here? In customer class, you want to order some food here. Okay, you want to order some food here. So we are done with this first half. So here you'll have main method. Okay. So first of all, we will create an object of hotel. Why? Because it's a non-static method here, order food. So now I will tell h dot order food and I pass it as 1. So when I give it as 1, order food of 1, the choice is 1. Is choice equal to 1? Yes. I'll create an idli object and I'll return I here. That is idli object. That is nothing but you can write it as food only. Okay, food only. And the type of food is idli right now. Okay, the type of food is idli right now. Okay, food ordered. I'll take a variable called as food ordered here. Okay, and that is idli as of now because it is 1. What if I pass it as 2 here? If the choice is 2, okay, dosa object got created and it is again return dosa. Again, there is a possibility of dosa object here. Okay, the same method only, but it might return different types of objects here. See, it might return even vada if I pass different type of data here. So I need a generic return type, no? That's the reason I wrote it as food here, no? The same return type I have to write it down over here. Okay, the same return type I have to write it as food over here. So if I write it as 2, it means the food ordered here is dosa. If it is 1, idli. So now I will check the references here. See, this I'll write it as obj. Okay, I'll just write it as obj here. If obj instance of idli, so you can downcast it over here. I'll just here it is. I'll just write it as ordered idli. Okay, I'm just writing it in a beautiful way. If you want, you can do this downcasting and access the properties of idli also. But I'm just trying to do it over here. Else if obj instance of dosa, okay, I'll just write it as sys out. Okay, so just a moment. Ordered dosa here. Okay, else I will just write it as sys out ordered vada here. This is all about it. Okay, so now here closely observe. Okay, order food of, I'll pass 1. Press Ctrl on your keyboard, hover on the method, click on that method. It goes to order food. And what is the choice I passed? 1. Is 1 equal to 1? Yes. Idli objects get created and I am returning an object of idli here. Return I meaning I'm returning an object of idli. So idli object is stored into obj. Why? Because return I meaning I is of type idli. And what is it storing? Idli object. So the idli object is written over here. That obj is idli object. Is idli object having the properties of idli class? Yes. Ordered idli should get executed. So when I execute it, did I get expected output as ordered idli? Choice is 1, ordered idli. So if I write it as 2, okay? If I write it as 2, choice is 2. Is 2 equal to 2? Yes. I have created an dosa object in D. D is nothing but the dosa object. That dosa object is returned over here and that is getting stored into obj. So is obj instance of idli? No. Is dosa object having the properties of dosa? Yeah. Okay. Is dosa object having the properties of dosa? Yes, it's true. Again, if I go over here, see, ordered dosa here. Okay, ordered dosa here. Got it? If I give it as something else, 3, imagine it is 3. Okay. So if I pass the choice as 3, is 1 equal to 3? No. Is 2 equal to 3? No. Else, I create vada object and stored v. So here vada object is returned. Is obj storing vada object? Is vada object having the properties of idli? No. Vada object having the properties of dosa? No. Else here, ordered vada here. That way, we can access it perfectly. Correct. But I have not downcasted over here, but we did it in the first example, no? Son, daughter, you'll downcast it to daughter and try to access the daughter class properties, son class properties. That way we can do it. But here optionally I have made sure this entire program here. Got it here? Did you all understand, okay, how a return type can be class over here? Everyone understood the program here? Okay, great. Okay, so I hope you all got the clarity about what is the importance of upcasting and downcasting later. Okay, and there's one question. After downcasting, while printing, you are using the reference of subclass. Can't we use the reference of superclass? See, whenever you make use of the superclass reference, I can access only superclass properties. But if you don't downcast it, no, you will again access, only generalized property. You cannot access the subclass properties. Therefore, always, once I'm accessing, we have to always make use of subclass property, not the superclass property. Okay, so this is how downcasting is also important here. Okay, I hope you all got the clarity of this entire topic which we discussed here, right? So I hope you all got the clarity about this entire process here without any difficulties over here. Okay, so if you want to give me one more example, if I'm taking a lot of your time here, guys, one day, I just don't take so much. If you're having, if you're getting late here, the videos are always recorded, you can watch it here. Okay, because I just don't want to break the flow, guys. Okay, understand, in my perspective also, I just don't want to break that flow. That's the reason I'm going here. If at all you're getting late for some other session or something, make sure you can quit the session, immediately watch the video here. Okay, I'll upload it. But I'll take one more example. Imagine I have a class called as coffee, okay, and I'll have a class called as tea here. I'm doing one more thing because I want complete clarity here. That's the reason. Okay, so now here I have a couple of classes, coffee and tea class. Now here I'll have one. Imagine you're in a cafe. Okay, cafe here. Okay, in that cafe here, you are having one vending machine. Okay, you are having one vending machine here. Okay, now, so now here again same. If here int choice, if the choice is 1, you will order coffee. See, if choice is equal to 1, what am I supposed to do? I have to create an object of coffee and I will return the coffee object. Okay, I will return the coffee object. Okay, now, oh, I'm sorry, I have to write C because object of coffee is C. Else if, okay, else if the choice is 2, I will tell, I will create an object of T, okay, T, and I will create an object of T over here, okay, and I will tell return T. Okay, so if the choice is 1, okay, if the choice is 1, I am returning an object of coffee. So my return type is supposed to be coffee. If the choice is 2, my return type can be T. So there is a possibility I can have 2 return types over here. There's a possibility that I might have 2 return types. But a single method cannot have 2 return types here. So I need to have some generic way of writing it. So what can I do here? Can you all tell me, guys? See, you're in a cafe, there's a vending machine. If the choice is 1, it's returning coffee object. So therefore the return type has to be coffee. If the choice is 2, you're returning a tea object. So the return type has to be tea. So there is a possibility it might return either coffee or tea. But I cannot have 2 return types over here. Okay. I need to have a generalized return type over here. So what am I supposed to do here? I just cannot write it as cafe also. I just cannot write it as cafe also. How is coffee and tea related to cafe? Without easy relationship, no upcasting. If you could closely observe, idli had a common class called as food. You cannot write directly. So what I'll do is, I will create, it's not that cafe, okay, it's not that you have to write it as cafe. You will create one class, okay, you will create one generalized class called as beverage here. Okay, can I write it as beverage here? Okay, it's a type of drink here. Okay, so here I'll make sure, okay, I'll make sure that coffee inherits beverage here. Coffee inherits beverage here, or you can write whatever you want it. Okay, so I'm just writing it into a simple way. And tea extends beverage here. So what did you understand here? Sir, beverage is one class, okay, wherein coffee is inheriting beverage class, okay, and tea is also inheriting the beverage class here. So what did you understand over here? Tea and coffee have a common superclass, and that superclass name is beverage here. Got it? So what should be the generalized form over here? So if it is coffee object, it should be coffee. If it is tea object, it should be tea. So there is a possibility that I could have tea or coffee, but I cannot have multiple return types. So what will be the common return type? Will it be your name, my name, beverage, cafe, or what? What should be the return type, guys? What should be the return type? Oi, answer everyone. What should be the return type here? Very good, very good. So the return type has to be beverage here. Why? Sir, coffee is having a superclass called as beverage and tea is also having a superclass called as beverage. So coffee and tea have a common parent. Okay. So that is the superclass parent here. Okay. I have done this. Okay now. But now still it's giving an error. What the hell, sir? Why the hell is it giving an error, sir? Can you think and tell me, sir? Tell me, why is it still giving an error? If you tell me, probably you are very strong at Java as of now. If not, you have to little bit of extra effort. Can you tell me why is it giving an error? If I hover on it, you will tell me easily. Okay, think and tell me, why is this error? Why is this error? Okay, one answer was, sir, there is some problem with respect to upcasting and downcasting. Absolutely no. There is no issues with upcasting and downcasting. Why? I can return coffee object, no, tea object, no, into a common parent called as beverage. No issues with upcasting and downcasting. Okay? Think and tell me. I want to take time today and do it. Okay? Because I want you all to be strong here in everything. Okay? Okay. I'll give you one hint. I'll hover on it. Okay? Tell me. What is it telling? The method, if I just hover on it, see it's telling. The method must return a result of type beverage. What does it mean? What does it mean? Did you understand something with this compile time error? The method must return a result of type beverage here. Oh, what does it mean, sir? I will tell you. I will tell you what is the problem. Okay, see here. Sir, if the choice is one, you are returning coffee object and it's a type of beverage. Very good. That's the reason there's no error in if condition. Okay. If the choice is two, I am creating an object of tea and tea object is returned. Okay, it's a type of beverage. What if I give the choice as 200, sir? If I give it as 500, sir? Is 500 equal to 1? No. 500 equal to 2? No. If and else is not, they are not getting executed at all. But still you have told the return type as beverage. What is it returning if I pass 10,000? 1 lakh. There is no return type for those at all. So that's the reason, if the above conditions does not satisfy, I have to return null here. Okay, I have to tell return null here. But what did I do in the previous example? See, if you could closely observe, where the hell is this hotel class? Hotel. So just observe what I did in hotel class. Okay, observe in hotel class here. Okay, in hotel class here, I just told, see, if the choice is 1, idli. If the choice is 2, dosa. If the choice is 3, 4, 5, 6, 7, it doesn't matter. I have directly written else and told return vada. So if it is 1 and 2, idli dosa. If it is apart from 1 and 2, it should always return vada object. So it is always vada is a type of food. So here I am not written else block at all. See, if the choice is 1, coffee. If the choice is 2, tea. But what if I give 200, 300, 400? It shouldn't return anything, no? So I have told it as return null. Return null meaning if it is apart, if it is apart from 1 and 2, don't return anything. So you can write it as return null. But here directly, rather than doing, you can here also you can write it as else if the choice is equal to 3, return vada. Then even this method will give an error. Why? If it is 1, idli. If it is 2, dosa. If it is 3, vada. What if it is 10, 20, 30? So there is no return statement at all. So you have to tell return null here. If none of the above conditions satisfy, you have to return null here. Got the clarity? So this is what we are supposed to understand over here. I hope you all got the idea over here now. Got it now? So I have to tell return null here. You understood, guys? Why is it null over here, everyone? Got the clarity here? Yeah, very good, very good, very good. Okay, so now this can also be done in a different way. Sir, how, sir? How can we do it in a different way, sir? I will tell you. See, rather than doing all this here, okay, you can directly write it as return coffee over here. You can directly write it as, just a moment, I'll write it down over here. Okay, so sir, what, sir? You're confusing, sir. No, 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 I'm not trying to confuse you all. You can directly return an object of coffee here. Okay, rather than creating and returning it later, you can directly write it as return new tea. Okay, that way it becomes efficient. No, see, don't you think so? Now your program looks good also. Complexity reduction here. See, if it is one, you are returning coffee object. If it is two, you're returning tea object. If it is something else, null. So coffee is of type of beverage, tea is also a type of beverage here. It works fine. Got the clarity here? If not, you had to make use of the second way. What is it? Create an object first and then return that object. Whichever way you are good at, you can use it. Okay. But now you're the customer. Okay, you're the customer here. Okay, so I'll have the main method. Okay, you are the user. I'll create one more class called as user. So now here, first of all, if I want to, oh, 1 minute, 1 minute, 1 minute. Okay, great. So what am I supposed to do? I will have my main method wherein the execution will start. Can I make use of scanner class here? Accept dynamic input, sir. I can do it in a beautiful manner here. Okay, no one is going to question me. Okay, so I will create an object of scanner scan s equals to new scanner. Okay, and I have to pass system dot in. Okay, and import the scanner class from java dot util package. Okay, I'm trying to import the scanner class from java dot util package. Okay, so why did I make use of scanner class? So I will make use of this data. See, enter choice. Okay, so enter choice, one for coffee slash n, 2 for tea here. Okay, 1 for coffee, slash n meaning it goes to the new line here. Okay, slash n means the oh, I'm so sorry, not backward slash, forward slash. Okay, this is backward slash. Okay, see, it goes to the new line. Slash n will go to the new line over here. So I'll take the choice here. In choice equals to s dot next end. So I have to create an object of cafe because it is present in cafe, no? That vending machine. So you have to create an object of cafe here. So here c dot vending machine and I'll pass the choice here. Okay. So now what happened? Imagine here. Cafe object got created. Scanner object got created. Enter choice. 1 for coffee, 2 for tea. I accept 1. The choice is 1. I pass c dot vending machine of 1 here. So I pass it as 1. Is choice equal to 1? Yes. Return new coffee, meaning it is returning an object of coffee here. So the return type has to be coffee obj. Okay. What if I pass it as 2 here? What if I pass it of 2? It is returning tea. So it is returning what? Tea over here. So the return type can either be coffee or tea. But I want a generalized return type, no? So that's the reason I'll write it as beverage here. Just simple. See, the return type is beverage. The data type here also should be beverage only. Okay. So now here I'll tell if obj instance of coffee drinking coffee here, you can just write it as sys out drinking coffee, else if obj instance of tea over here, I am supposed to write it as, okay, drinking tea over here. Okay, else I'll just write it as invalid choice here. See, it works fine. Okay, it works absolutely, it works fine. Okay, so now you have to just understand the flow here. See, now when I execute it over here, I'll write it as 1. Can you see? Drinking coffee. Is it working fine here? Because the choice is 1, drinking coffee. I execute it again, 2, drinking tea. It works fine. If I give it as 5, see, invalid here. Okay, that's it here. See, if I pass it as choice here, 1, the choice is 1. Is 1 equal to 1? Yes. Coffee object is returned here. So obj is storing coffee object. Is the coffee object instance of coffee? Drinking coffee. Is if it is tea object instance of tea? Drinking tea. Else it is invalid. So that way we are just supposed to understand the basic flow and try to work around with the content here. Got it? It's a very simple program which we have done here, but you're just supposed to see the data here. First, guys, we had two types of objects. If a vending machine might either return coffee or it might either return tea. Since I want a generalized return type, okay, I'll create a class called as beverage and make sure it will inherit the beverage class because they both have a common superclass. Now, if you go to a cafe here, okay, there is a possibility if it is 1, you are ordering coffee. If it is 2, you are ordering tea. So if it is apart from that, it's null. So I want a generalized return type, no? So it is beverage here. So once you tell vending machine, it might either return coffee also, tea also. Again, I want a generalized return type. So it is beverage. So if it is an instance, if the object is an instance of coffee, drinking coffee. If it's an instance of tea, drinking tea. Else it is invalid. So this is all about the entire process of understanding what is upcasting and downcasting here. The basic things which we are supposed to understand when it comes to upcasting and downcasting here, right? So I hope you all got the basic idea of it. Clear? So we are done with the entire process of understanding what is upcasting and downcasting here. Okay.